Welcome to Brain Vision.
In this question, we are told we have a region of air which is in the space of a width d. The absolute temperature of this air increases linear from T1 to T2. We have these values listed here on the right. We want to find the time taken by the sound wave to go through this region. So what we know is that at any position x, the temperature variation can be given by T. It's shown in this expression here, where T is equal to T1 plus T2 minus T1 over d, x, where x is any position. We also know that the velocity is proportional to the square root of the temperature. So what we can do is we can say that Vt over V is equal to the square root of T over 273. Because we know that V is 330 for a sound wave at 273 Kelvin. So what we can also say is in terms of V, this becomes that Vt is equal to V multiplied by the square root of T over 273. What we also know is that Vt is equal to dx by dt, so the rate of change of position with respect to time. So we can rearrange this and say that dt is equal to dx over vt. Now that we've done this, we can substitute in and integrate. So we can integrate both sides, the left with respect to t and the right with respect to x. What we'll first do, though, is say that t is equal to the square root of 273 over capital T, so dx by dv multiplied by the square root of 273 over t. So now that we've done this, we can go ahead and calculate the integral. So t is equal to 273 over v, the integral over the width, so from d to 0, 1 over t, where t is this expression, so we can substitute this in. So t1 plus t2 minus t1 over d x all to the half, because it's in the square root, dx. This gives us that t is equal to 2d over v square root of 273 over square root of t2 plus the square root of t1. Now that we have obtained this, we can go further and calculate by subbing in d is 33 meters. We know v is the speed of sound, so 330. We know t2 and we know t1, so we can say that t is equal to 2 times 33 over 330 times the square root of 273 over the square root of 280 plus the square root of 310, which gives us a final value for the time as 0.096 seconds. And that is our final answer for the time that it takes the sound wave to travel through.